Okay, students, today we're going to do lesson 6-4. You're going to need pages 367 through 371 tore out of your book. And this lesson today is going to be on estimation. When we estimate something, we're not getting an exact answer. We're getting something very close to that. So, there'll be different ways to go about this. And I'll just be showing you my way today. And then you can use my way. Or if you can think of a better way, you may use that. So, it says that Sarah wants to score 78% on her next test. Apparently, she knows something that maybe she's got to score 78 to get a B or to keep her A or whatever. So, she wants to score 78%, and I'm assuming 78 or better. She knows that the test will have 40 questions. So, she wants to know how many of these questions do we have to get right out of 40 to get that 78%. So, our I-CAN statement says we're going to estimate the percent of a number using equivalent fractions, rounding, or compatible numbers, things that we've already learned. All right, so part A down here. How can Sarah represent the situation to help her determine how many questions she needs to answer correctly? Well, I don't know if you agree with me or not, but 78% is approximately 80%. And 80% means 80 out of 100, which reduces to 8 out of 10. So if I were to break this test up into batches of 10 questions, okay, so let's say, let's make us a graph here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 questions. And let's make 4 rows of 10 questions. 1, 2, 3, 4 rows of 10 questions. So here we go. Each one of these boxes is going to represent a question. All right? So if I'd have to get 8, let's shade 8 of these, 8 out of 10 for this row to represent 80%. And I would have to do the same thing for each row. Whoops, shouldn't have shaded that one. I'm sorry, I got in a hurry there. We'll take that back off. So on each one of these rows, we're going to shade 8 out of 10. We're going to leave 2 open on that row and 2 and 2 and 2. So this has got 8 out of 10, 8 out of 10, 8 out of 10, 8 out of 10. So that's 8 times 4, that's 32 out of 40 questions, and that would be 80% correct. Okay? And that's about as close to 78 as we can get by estimating. That's how I would do it. Okay? Now, you should remember that 78% means 78 out of 100, but 78 is real close to 80, and 80 is easier to work with than 78 is. So remember, we're not working exact, we're working getting close to. Now, let's look down here at one more question. On her last test, Sarah answered 82% of 60 questions correctly. About how many questions was that? Okay, so let's do some equivalent fractions. 82% means 82 out of 100, and the of means a total, so it would have to go over here. So to get an equivalent, here's my variable. Let's put Q for questions. 82 out of 100 would be how many questions out of 60? Now, if you remember, when we have an equivalent fraction set, or a fraction set equal to a fraction, we're going to multiply the 2 that are in the diagonal position that we know and divide by the other one. So, we're going to take our little calculators and multiply 82 times 60, hit equals, and then divide by 100, and 49.2 questions is the exact answer. Well, you can't have 0.2 of a question, so you're going to probably have to round that up. We can't round down or she wouldn't get this percent. So I would say 50 questions. Now, if you want to do that by estimation, 82% is very close to 80%, like we did up in the other question. And then, because this was doing it accurately, 80% is close to 82, and this total number of questions down here was 60. And so there's that right there. Okay, so what's 80 times 60? 6 times 8 is 48, and put 2 zeros on it, so that's 4,800. And then divide by 100, and so that would be 48 questions. Now, when we did this by estimation, here's something we've got to talk about. We used a number less than 82. So we know our estimated answer is less than what it actually was. Let me say that again. When we estimate and we go under what it was, then when we get finished, our estimated answer will be under what it really should have been. All right, let's turn the page and look at example 1. You will see a lot of pie charts on standardized tests. They like them. They use them in the business world a lot when they're trying to have a meeting and show the people in the meeting things. They like to use things like a pie chart to show that. Very quickly, you can look and see that the biggest piece of pie here is 46%, and you can look over here and tell that that is browned. Okay? About a fourth of it, because this is almost a 90 degrees here, about a fourth of the eye color is blue. I would say that's closer to maybe a third. No, not a third. 45, a quarter, a little over a quarter maybe. And that's green, so that's green eyes. And then this little sliver here is pink. That's hazel eyes, and that little orange slice right there is gray eyes. Okay? So this graph shows the eye colors among 500 students. So this data is for 500 people. So according to the graph, 46% of the students have brown eyes. Okay, so that's 46% of 500 people. So how can we figure out the brown eyes? Well, we've got 46%. 46%, if we're estimating, is close to 50%. 50% is about half. 50% is about half. So we want about half of 500 people, which would be 250 people. So notice they say about 250 students have brown eyes. Now then, did we round the 46 up or down? Well, we rounded it up to 50. So do you think there's 250 people that have brown eyes, or would it be less or more than that? So it would be a little less than 250 people have brown eyes. But that gets you close. Okay? So let's look at the blue eyes. 23% is very close to 25%, which is a fourth. Remember some of those that you're just supposed to know? A fourth is 25%. So 23% of 500 is about a fourth of 500, and a fourth of 500 is 125. So about 125 students have blue eyes. Now again, did we round up or down? Well, we rounded up, so I would say this is a little bit too high. It's really going to be a little less than 125 students. Okay, let's look at this, try it. Suppose the graph, now they're talking about this same graph. So the percentages are the same, except this time, instead of having 500 people, there's only 120 people. So suppose the graph shows eye colors among 120 students in the 6th grade. About how many 6th grade students would have green eyes? So let's look at our chart. Green eyes is the green piece of pie, and it's 16%. So we're going to start with our 16%. Well, 16% is very, very close to 20%. And 20% is easier to calculate than 16. So we're going to round it up to 20. We're estimating. and I want 20% of 120. So I want 20%, and then my new total now is not 500, it's 120. So I want to know how many people have, let's make that green for green eyes, G for green eyes. Okay? So 20 times 120 divided by 100. The green-eyed people is going to be 20 times 120 divided by 100. These two multiplied together divided by that one. Well, look here. 0 cancels with that 0. That 0 cancels with that 0. All I really have left is 2 times 12, which is about 24 people with green eyes. Now, is that a little high or a little low? Well, we rounded up to 20%, so this is a little high. Our estimation is a little high, and you need to be able to tell me that. Okay. I'm not going to ask you to do the convince me. We're going to go on to example 2. Example 2 is use rounding and compatible numbers to estimate. Okay. Use the results of the survey shown to the right. Here's the survey. It says 53% of the 94 students surveyed, so their total is 94, and 53% plan to get a summer job. Okay, so it says you can use rounding or compatible numbers to find a reasonable estimate. If we round this to 50% and we round this to 100, it's going to get us close, but we've rounded 2 numbers doing it that way. Okay? If we round this to 50% and we round this down to 90, then half of 90 is 45. There's one answer. And again, we rounded 2 numbers. We rounded this one up and we rounded this one down. So we went up on one number, down on the other number. Now look over here. We rounded this one down and we're going to round this one up. So we're going to round this one down and we're going to round this one up. So it's going to have half of 100, which is 50. So doing it one way gets you 45 as an answer. Doing it another way gets you 50. Now, notice the little sentence down here at the bottom. Both 45 and 50 are good estimates for the number of students who plan to get a summer job. This is not an exact, there's no exact answer here. It's how you do the rounding. You need to round closely, and you will be close with your answers. Okay? Let's see if we can attempt to try it and fill in their boxes. This is more difficult sometimes, but let's try it. Students in another survey were asked whether they plan to attend summer camp. Out of the 56 students in the survey, 44% said yes. We're going to use rounding and compatible numbers. Compatible numbers are numbers that are easier to work with, okay, to estimate how many students plan to attend summer camp. So we're going to use rounding to estimate 44% of 56. Well, 44% is very close to 40%, and 40% is the same thing as 40 over 100, or 4 over 10. They left out the 40 over 100 step. Okay? And then if we reduce that, 2 goes into 4 2 times, and 2 goes into 10 5 times. So that's 2/5. Now 56 rounds to 60. It's close to 60. All right, so now then we want 2/5 times 60. Well, how many times does 5 go into 60? And then multiply that times 2. Or, with your calculator, I know some of you are not used to using a calculator, 2 divided by 5 equals, and then times 60. 2 divided by 5 equals times 60 is 24. So the answer should be 24. So then you have to say about or approximately, because it's not an exact answer, about 24 students plan to attend summer camp. Okay, this was by rounding. This was by rounding. Okay, now we're going to use compatible numbers to estimate 44% of 56. So we're going to go to 40%, and 40% again is 4 out of 10. It's 40 out of 100, which reduces to 4 out of 10, which is 2/5. And then what is a compatible number for 56? Well, 60 again is a compatible number. 50 is a compatible number. We can go down on this one. And it's going to work well. Compatible numbers work well. I've got a 5 here, so I'm going to round this down to 50. 50 is a compatible number for 56. So 2/5 times 50. Well, 5 goes into 50 10 times, and 10 times 2 is 20. So this one says about 20 students plan to attend summer camp. Now, I've got a difference of 4 here in my estimated answers. Okay? But they're both very close to each other. All right, let's go to page 370. Okay, here's your 2 examples. Here's one example of rounding. Here's one example of compatible numbers. All right? And we'll do whichever one it says to do, or do it the way we choose to do if we have the choice. How can you estimate to find the percent of a number? How can you do that? We're going to use rounding or compatible numbers. We're going to use rounding or compatible numbers. We're going to use rounding or compatible numbers. All right, number 2. Is there more than one fraction you could use to estimate 27% of 200? And I say yes. We could round this to 25%, which would be the same as a fourth. Or we could round it up to 30%, which I say is about 3/10. Then we would multiply a fourth times 200, or we would multiply 3/10 times 200. It says, is there more than? We say yes, there is, and here they are. Here's one, here's one. All right, let's look at number 3. What compatible number could you use to estimate 75% of 35? 75% is 3/4. So I could use 3/4 and multiply it times and round 35. 35 is approximately 36, and I know 4 goes into 36 12 times. So 3/4 times 36. 4 goes in there 12 times, and 12 times 3 would be 36. There you go. All right, number 4. Out of 195 students, 9% have hazel eyes. How can you estimate the number of students with hazel eyes? Well, 9% is ever so close to 10%. Okay? And 10% of, I'm going to round this up to 195 is ever so close to 200. 10% of 200 would be 20. That's 10 over 100 times 200. 100 goes in 200 2 times, and 2 times 10 is 20. Ever so close. We're estimating. We're not getting exact answers. Tomorrow and the next day, we're getting exact answers. But when you get an exact answer, you need to know whether it's reasonable or not. So if you know how to estimate a little bit, then you kind of know what the answer ought to be. Then when you work out a problem, you'll know whether you're in the ballpark or not. All right, do you know how? Let's fill in their boxes. 47% is real close to 50%. 77 is real close to 80. So we want 50% of 80. Well, 50% is a half. So what's a half of 80? 40. There you go. This right here is a half, and that's 80, and a half of 80 equals 40. Okay, let's look at number 6. 18% is ever so close to 20%. 48 is ever so close to 50. So we want 20% of 50. Well, 20% is a little less than half, isn't it? So when I get my answer over here, it ought to be less than 25. Okay? So I want 20 over 100 times 50. Let's see, that 0 cancels, and that 0 cancels, and 2 times 5 is 10. I say the answer is 10. Estimated. It's about 10. Number 7. 73% is really close to 75%. And we want to multiply 75% times this 800. I'm going to leave it 800 because it's already kind of rounded. Well, 100 goes into 800 8 times. If I just knew what 75 times 8 was, I'd be done. And it's 600. And you have a calculator, or you can do that by hand. We are estimating. Okay? So 31% is ever so close to 30%. And 94 is really close to 90. So I'm going to do 30% of 90. Have you learned that of means times? Of means times. Okay? So 3 times 9, that's 2,700 across the top. 3 times 9 is 27, put 2 zeros on it. I got 100 on the bottom. These zeros cancel, so my answer should be 27. The book did it a little bit different way, and they got 30. Am I wrong? No, 27 is very close to 30. Okay, Tara sent party invitations to 98 people. 82% of the people said they will come. About how many people said they would come? So, 98 is ever so close to 100, so I'm going to use 100. And 82% is ever so close to 80%. So I want to know how much is 80% of 100. Well, wouldn't it be 80 people? Plan to come. 80% of 100 of means times. 80% of this total is 80. Okay? Turn the page to 371. There's a couple more of these that you need to do on your own. There's about 4 of these right here that you need to figure out to round this up or down, up or down, up or down, up or down, and work with those numbers by either rounding or compatible numbers. So you're going to work on these 10 through 19 on this problem-solving page. And I am leaving the vocabulary and the reteaching page for you. I need to help you with this pie chart though, so you can read it well. Okay, this pie chart this is all one piece of pie. It's 43%. So you just can't see the border of it. There's 1, 2, 3, 4 pieces of pie here. This whole light colored piece is 43%. And it represents hamburger. So this is hamburger. And let's see. It looks like the darkest one. Looks like the very darkest one is baked potato. I think this one right here is the baked potato. We'll work it that way anyway. And the other one, next lightest color, is pizza. I think this is going to be pizza. And that leaves this to be meatloaf. They haven't had my meatloaf. I make a good meatloaf. Okay. So we're going to label it that way and work it that way on this sheet. Okay? So you have a vocabulary page. You have a reteaching page to do. You have that one and this one. And then you have your practice and problem solving page. You've got plenty to do. All right? So get busy. And we're only spending one day on this estimation. We're moving on to getting real answers, using our calculator, and getting very accurate answers after today. But it is important to know how to estimate. So, lesson 6.4, it's on estimation. We're only spending one day. And I'll see you later.